How do you apply transition delay faults? Let us say there is a node here. We suspect that it is too slow to rise. So we have to, just like in stuck at faults, we have to activate this fault. We have to make it go from 0 to 1. So we will need one vector V1 which will cause this output to become 0. Okay. Let us say this node is called X. So apply one vector to set X equal to 0. So that means you have initialized that node to 0. Then apply another vector to set X equal to 1, which causes the transition, and also adjust X V1 and V2 such that and propagates the transition to a primary output, or any output for that matter. It does not have to be primary output, to an output. Could be also a state. So let me show you an example. So let us say we have a circuit like this. This is an OR gate. So suppose we call this A, B, C, D, E. Let us say we are worried about a transition delay fault here, slow to rise. Then we have to first place a 0 there, and we can do that by placing a 1 1 here. Place a 1 1 here. That will cause a 0 here. In order to place this 1, maybe we can place a 0 here. The others are X's. So we were able to place a 0 here, making this 1, and in order to make this a 1, we need both of these to be 0. My apologies. Both of these must be 0. Now I have to make this a 1 in the next vector. So V1 is 0 0 0 XX. What is V2? V2 must cause maybe one of these to 0. Okay. So easiest way is maybe A or B should be made 1. So we can make A equal to 1. that will cause this to go from 1 to 0, and that will cause this to go from 0 to 1. And we have to allow this transition to propagate, so we have to put a 0 here. That means we have to put a 1 here. That means this will be a 0. Oh, unfortunately, we will not be able to test. Okay, see, this became 0. This became 1. Okay, so this won't work. Okay, why? Because I was able to launch the transition, no problem, but to propagate it, I need a 0 here. That can only be done by putting a 1 here. The moment I put a 1 here, this will become a 0, and the output will become 1. There is no transition at the output. Okay. So, in this case, there is no way to propagate the transition along, this guy. Okay. Let us pretend that there is another output here. Then this 1 to 0 transition can go here, and if you make this 0, this will become a 0 to 1 transition. So, you can see that we applied a 0 to 1 transition that propagated along this path. We could not propagate it along this path over here. So, this path I could not propagate. So, the test vector was initially, this was x, I guess. Okay. So, we will have to have x here. Then A, B, C are 0, 0, 0, and then D and E are x. So, this, let us call this as F. Then A will become 1 and F will become 0, right. Then B, I suppose, remained 0. Then this remained 0. Frankly speaking, they can be anything, because we are not transitioning along this path. So, B and C can be XX also. And D can be XX. So, these are the two vectors. So, important point is to detect a transition delay fault, we need not one but two vectors. V1 to put an initial value, so in this example V1 is making this node 0, and V2 will launch the transition, and also propagate it to an output. So, in this case it went to this output. So, how do we actually test? In this example, we will apply F, A, B, C, D, E we will apply x here. X means it could be either 0 or 1. X 0 0, these are called care bits. Okay, x means don't care bits, 0 and 1 are care bits. So x equal to 0 0, x equal to f equal to x, a and b are both 0, c is also 0, and then the other two are also x's. This is V1. Then after the circuit responds to this, we bring in the other one, that is 0 1 x x x x, that is V2. Now the transition will be launched and it will be available here. This output is, let us say, Z and Y. So at the Z output the transition is available. So applying a TDF test vector. So here is my circuit again, and here is my scan chain. These are my state outputs and these are my state inputs. I will show only 3. So these are my D flip flops. I have converted them into a scan chain so that I can initialize them to any value I want. See, applying V1, we can use a scan chain. So no problem, we can apply V1 by shifting in the appropriate value. So in my example, I had to apply x00 xx. Okay, so x can be treated as 0. So in my example, x then 3 zeros, all zeros. Let us say it is 1 2 3 4 5. So I can simply shift in the values. Okay, all zeros can be shifted in. Six zeros. Now what about V2? V2 demands that f should be 1. Okay, that f may be here. Now how do I get 1 there? Right. I'm sorry, f should be 0 and a should be 1. My apologies. A should be 1, right, and f should be 0. F is already 0 here. Now we can't do V2, V2 cannot be scan shifted. I hope everybody have understood that. V2 cannot be scan shifted. Why? Because shifting in V1 is a slow process. Okay, we take, like in this example, 6 clock cycles to shift in V1. Now, if I shift V2 in the same way, the transition will not get launched. Okay. Before the transition is getting launched, all kinds of other activities are happening in the circuit. We need to bring a 0 here in I think it was A, right? A was the one which was to change from 0 to 1. So, we want to change A from 0 to 1. We must change A to 1 immediately after this. Okay. Now, if let us assume that this A is, it is this guy. Okay. Let us say this is D and this is Q. So, look at what has happened. Initially, I made this 0, I made this 0, etc. I applied all zeros. That resulted in a 1 here and a 0 here. Now, if I capture, A will become 1. Okay. So, if I capture after applying V1, if we capture, A will become 1. So, we lucked out. Okay. We got the transition that we were looking for. We also need to make sure that F is 0. Okay. You also need to make that F is 0. I think here I wrote it 0. So, F should become 0 in the. Now, if F is a primary input, there is no problem. Okay, we can make that happen. But if F is coming from some other flip flop, we must adjust that such that F becomes 0. So, if we do like this, then A will go from 1 to 0. And it will cause this transition to be launched, and it will get it will be visible at this output. So, let us say this goes to another flip flop, something like this. I hope this is clear. I will repeat it. So, understand the main thing. Okay, to launch a transition delay fault, what is a transition delay fault? We pick a particular node, in this example this node X. Okay, this is the node that we are worried about. We want to we worry that it is too slow to rise. So, what do? We start by placing a 0 here somehow. We can work backwards and figure out what will cause this node to become 0. Then we adjust the inputs in such a way that this becomes a 1. And we know that when we do that, the transition from input to output will be visible here, and we check whether that one gets captured there or not. Okay. So, apply V1, apply V2, that causes a transition to occur, and then capture. If we see a 1, then we are good, that circuit does not seem to have a path problem, because it is already transition. But if we see a 0, okay, that means this did not change to 0 at all. It was supposed to change to 0 when I apply the V2. So, something is wrong. It is possible that this node is slow to rise. We cannot point and say that is the only reason. Okay, there may be some other reason for that node to not transition to 1. Okay, but definitely this could be one of them, the node of interest. Okay, so let me repeat. Okay, apply V1, apply V2. So, by doing this, launch the transition, and then capture, capture the output, and then check if it is the desired output. If it is not, then declare that there is a fault.